Our next application is going to be Clairvaux from Tjandra. And he's also connected via Skype, yes? Yeah, sort of, okay. Well, hopefully that works. Let's watch his video and we'll try to connect with him.
The name of my project is Clairvaux. It's a web application that predicts armed conflict events using Numenta's technology. And what I mean by that is basically it's the HTM, the hierarchical temporal memory. And the data for this application comes from the site ACLED, the Armed Conflict Location and Event Data Project. And they provide data going back to 1997 describing armed conflicts in the African continent. But what I've actually used for this project are these monthly files. And I've loaded a few of them already for this demo, so we can look at one of them as an example. So here we see that the HTM network made over 2,000 correct predictions out of over 13,000 predictions. And in order to get these numbers, it had to be trained this many times, which is really the number of rows in the file times training cycles constant, which is 10 in this case. And the accuracy is just the correct predictions over the total number of predictions. And in order to look at this in more details, we have this thing called a co-occurrence matrix, where the rows are the actual events and the columns are the predicted events at the next step. As you hover over each cell, you can see the counts as well as the probability distribution. So here we see that this is the count and the probability of having seen this event. This is the count and the probability of seeing this event at the next step. Now this co-occurrence matrix tells us what the network is predicting, but we also want to have some idea of the accuracy, and that's what this confusion matrix is for. And here the rows are the predicted events and the columns are the actual events. And the correct predictions are shown in green along the diagonal entries here. So in this case, the rows here are in red are basically false negatives, and or the numbers in this row are false negatives, and the numbers in red here in this column are false positives. So as I add more data, it's the accuracy starts to improve here at about 30%, and here we're at about 40%. So it's possible to see this number go up even higher as I add more data. I've only put just a few files here for this demo. And it's also possible that some of these events may be more or less random, so there's not really a pattern that could be used to make predictions about them. Or some events may have some pattern, but we just don't have the right features to make an accurate predictions about them. So what's the use of something like this? Well, I think it could be used by a government or a research organization, for example, to better understand armed conflict events. They may be able to detect, for example, if there's a domino effect where one event leads to another event, or an escalation where one particular event escalates to a more severe event. And it may also be used as a means of a way to take action to either prevent or mitigate an armed conflict event from happening. So I believe there is a use case for this kind of application. And that concludes my presentation. Thank you.
All right. So looks like we've got Donnie on audio. Hello, Donnie. Thanks for joining us. And let me just, before going to the panel, so from what I understand here, based on all of the armed conflict events in Africa, Donnie's feeding them in and trying to predict what the next type of conflict is over time. So basically using, trying to classify what type of category is coming next. So. Okay, hey, Donnie, are you there?
Yes.
All right, he is there.
Yes, yes, I'm here.
Okay, we're going to ask you some questions about your project. Thanks for joining us.
Sure.
Go ahead.
Sure, thanks.
Yeah, I have to say, of all the ones that we saw, this was the one that kind of really opened my eyes about the possibilities of kind of real-time monitoring and, some really innovative uses of this. And just to the idea of monitoring conflict globally and being able to predict where armed conflict might happen next, I thought was a really, really nice idea. I think you're, if I remember correctly, you're a little bit limited by kind of the real-timeness of the data that's available today. But I think you could imagine that in the future, this could be really, constantly streaming data and could be a really nice application for just monitoring geopolitical events. So this is a really nice, innovative application. I do have one question. Did you try to look at, you had that 40% accuracy, and I guess since you have 9 categories, it looked like chance is around 11% or so, maybe a little bit higher. Did you get a sense of whether, and it's obviously a pretty random thing as well, did you get a sense of whether 40% is a good number? And a second follow-on question is, NUPIC can predict sort of probability distributions over events. I wonder if you tried to look at that to see if there was some way you could give a confidence estimate to the prediction. So maybe some types of sequences are really random, but there are some types where you can pretty confidently predict that this next conflict is going to happen.
Sure. So I've actually spent more time analyzing the data recently, and so on the GitHub repo, the README file, I actually put my conclusions there. But basically, there are 3 events that are very frequent, which are the riots and protests. The second one is the battle, no change of territory, which is basically like a rebellion where the contested location doesn't change. And the third one is the violence against civilians. And so the HTM, it can predict the riots and protests really well because it has a high count in the data. But the other types have low counts. So that's why that's why it's it's not getting accurate predictions for them. So I've basically I basically tried to running locally with monthly data on my local machine starting from January up till about October, and what I can see is that at the beginning, it's the HTM is sort of like making random guesses in the co-occurrence matrix. It's showing us colored cells in all the columns, but as I progress further up in time, so when I'm looking at the October's data, for example, it's really showing just colored cells just in one column in the riots and protest column, which means that it's getting more confident about predicting that event, but not so much about the other events because because there's not enough data for them yet. But then it's also starting to learn to predict about the second most common event, which is the battle, no change of territory. So I think if as more data is fed into it, it will start to learn to make predictions on the more common event types.
Yeah, to continue about the data, I wonder, have you tried other data sources? For example, I know there is the San Francisco crime map where it's also, so you can get this data live and it's classified by gun crimes, assaults, things like that. That would be interesting to feed to your system.
Yeah, I mean, they are similar in some ways. I mean, they're human-generated events. They have a timestamp and location. So I think it would be possible to feed the data and see how it would work. And well, the visualization itself probably is not going to change that much. It's just the matrix of categories. So I haven't really looked at the climb map data, but I guess they have different categories for the different climb types, and so I think it is possible to use this for many different event types, not just for this particular data set.
But it's more about the nature. I think you can just use their API to plug this live into your system instead of uploading CSV files. So because it's the same type, then that would be interesting to see if you can get this live source.
Okay. Yeah. Well, like right now, the code is hard coding a few things. Like the encoders is hard coded for the specific fields, but I think with a little bit more work, it is possible to make something that's more flexible. So it doesn't work on. So it's not really hard coded only for the specific data set, but it could potentially work with other data sets.
Thank you.
I thought this was a really fascinating kind of application. I'm curious, I couldn't make out the specific names associated with the rows and columns, but my question is, in any sense, do you view this as actionable? Okay, so let's say to go back to the air traffic thing, you view this as predictive, that you see a strong signal that some next event will happen. Is that interesting or actionable?
So I'm not really I'm not really an expert on national security, for example, but I think it may be of use for like a government organization or someone involved in national security, for example, to if they right now the event that it's most confident on is the riots and protests. So I'm not sure like exactly what kind of actions one would take when they see that that this event is predicted to happen on the next day. But I think for some of the other events that are more extreme, like the battles where some fatalities are involved, I think it could be something that could be used for someone to make some decisions. For example, to either like find a way to prevent that event from happening, or maybe take some actions to maybe move some resources around or move some people around to minimize the damage, for example.
Or prepare defense, prepare civil defense, like hospitals, systems, or numbers of police or something.
Yeah, because some of these events have fatalities. So, for example, riots and protests probably is not going to have any fatalities, but some of the more extreme ones, like the battles and the armed conflict events, they do have some fatalities. And the fatalities are actually in the data itself, but I didn't use that in this case for classification.
It's a lovely, ambitious application. I'm not convinced that the patterns in the data that you could act upon. On one extreme, you're trying to do something like predicting earthquakes. Well, you can classify them, and you can say the percentage that are in different types, but it's not. It might be there. I don't know. But you also might have just ended up predicting the first order, zeroth order prediction of likelihood. So.
Well, this is data across all of Africa, I believe.
It's across all of Africa, but online I asked him about the questions. He said he parcels it up for different reasons.
Oh, okay.
Because if it was across all of Africa, then you're mixing sequences of different things, and it might be a little hard to do. So I think I love the idea. I'm not sure that if the data itself is sufficient to make a good prediction on these things. But that's what I would be thinking. I'd be thinking like, what other things that are like this that maybe I get more data that might be more predictable and sequential. It's just it's an unproven hypothesis, and you end up predicting the most likely events, especially if there really is there isn't temporal structure in the data. That's what it'll end up doing. So that's it's just something to be concerned about and ask, could you get around it?
Well, in a way, it's an interesting experiment to see if there is a pattern in something you wouldn't intuitively think there is a pattern for. I think I would think that conflicts are somewhat random. Like I guess you're making the argument that conflict begets conflict, and therefore there is some sort of a pattern. Therefore, the conflict that happened.
Protest, battle, or rebellion.
Yeah.
Right.
Well,
And so it's interesting to see if there is a pattern there.
Yeah. You'd see that, you could only see that here if the predictions got better than that zeroth order prediction.
But the big challenge is, of course, you're not predicting when there's going to be something, but that the next one will be of this type.
Wait till next year.
I mean, another way
You have to
to
know when the next event's going to be to act on it, of course.
I mean, another way to think about it is, maybe think about what kinds of sensory systems would be able to help predict that. So maybe you can somehow, see how many crowds are accumulating, or some other sensory system that where you might actually have temporal
media,
sequences that could potentially predict it, and it might be very different in different geopolitical scenarios.
Correlating this with looking at streams of Google searches would be very
that's
interesting.
an example. Yeah.
As a way
There's
of
a lot of
enhancing.
different factors that could be used to identify when a conflict is coming on the
But
internet.
the rarer the event is, the harder it is to predict it. That's why I use the earthquake example. And again, you may say, hey, they're predicting earthquakes here in Northern California. We know it, but when? So we don't do anything about it. You put some water in your basement type of thing. I was wondering, you could also we were brainstorming, we should probably keep going, but there could be other things that are less than armed conflict. There might be things like food shortages or transportation shortages or other things that might be more frequent, perhaps less significant, but more predictable.
Disease outbreaks.
Diseases, but things that might happen on a fairly regular basis that you could track, and then they might be, the more often they occur, the more actionable they become as well. So,
This is another example of this data stream of events over time in different places, which I think is...
We ran into this very similar issues when we were looking at credit card fraud, lots and lots of data, and then there's a fraud that might occur, but it's too rare an event sometimes to make it a predictable data stream like in that regard.
Right.
Anyway, but very, very cool.
Okay. Thank you, Donnie, for your novel application. Okay.